Harsha AJ. So today we will discuss about normal distribution. So in the last class itself I explained there are two types in continuous probability distribution, right? The first one is exponential distribution that we have discussed already in the last video. So in this video let us try to understand the basics of normal distribution and how to check the table using the given data table. So later in the next video we'll try to understand the problems on normal distribution. So the definition is the continuous probability distribution having the probability density function f of x equal to 1 by sigma into square root of 2 pi into e power minus x minus mu whole square by 2 sigma square, where x and mu lies between minus infinity to plus infinity and sigma is greater than 0. So this is called normal distribution. So try to remember this formula. Now this is for general. Now for any particular interval, say a to b, since this is a continuous distribution, same formula we have to take, but now the interval becomes a to b. Therefore p of a less than or equal to x less than or equal to b, it is 1 by sigma times square root of 2 pi integration a to b e power minus x minus mu whole square by 2 sigma square into dx. Now one more speciality of normal distribution is, in this case mean, variance and standard deviation is equal to mean, variance, standard deviation of the given distribution itself. That means, see, when we studied exponential or when we studied Poisson binomial, we have separate formula, right, for mean, variance and standard deviation. But here they are exactly same as the given distribution. So there is no special formula. So that is one advantage over normal distribution. Now here the problems is basically we are dealing with the graph. Therefore we will try to plot the graph for normal distribution. The graph look like this. When you observe this graph, so this is clearly symmetric above the line x equal to mu, right? What do you mean by symmetric? The area bounded by right side of the line x equal to mu is exactly same as the area bounded by the left side of the line x equal to mu. So that is the curve for normal distribution, and this is called bell-shaped curve. Okay, so try to remember this graph especially for normal distribution. Okay, so these are the three major things we have to observe. Now let us go for the next step. Here we are not dealing with normal distribution. There is an additional step called standard normal distribution. What is that? Let us try to understand. First we take any interval a to b. Just now we know the formula. It is 1 by sigma times square root of 2 pi integration a to b e power minus x minus mu whole square by 2 sigma square into dx, right? Now what I will do is, in place of x minus mu by sigma, I will introduce a new variable called z. This substitution is called standard normal variate. In short, SNV. So try to remember this formula. What we are doing, I'll repeat again. In place of x minus mu by sigma, I am writing z, which means anyhow mu and sigma are constant. I am representing x in terms of z. After this substitution, I will simplify. I have not written any steps here. You just remember the formula. Now p of a less than or equal to x less than or equal to b. X we are writing in terms of z. So variable changes from x to z. I have taken the constant as z1 and z2. So p of z1 less than or equal to z less than or equal to z2 is equal to 1 by square root of 2 pi integration z1 to z2 e power minus z square by 2 into dz. So this is the simplified form. I have not explained any step. You just remember the formula. One major observation is, in the case of normal distribution we are writing in terms of x. In the case of standard normal distribution we are writing in terms of z. Therefore you just observe equation 1 and 2. What is the difference? It looks to be almost the same, right? See, only difference is there we are writing in terms of x. Here we are writing in terms of z. Now technically the difference is, here in the second formula the value of sigma is 1 and the value of mu is 0. Therefore the meaning of standard normal distribution is this is same as normal distribution with the substitution mu equal to 0 and sigma equal to 1, and that is called standard normal distribution, and that is denoted by phi of z. Therefore, throughout in any formula, any problems, any solutions, we prefer to convert normal into standard normal distribution while writing in terms of z. Now, the interesting question is, what is the nature of the graph now? Technically, again the graph is same. Since mu equal to 0, the given curve becomes symmetric about the line f of z. That means left side of the origin area is same as right side of the origin. Again it is bell shape. There is no difference. The fortunate thing is this is symmetric. Now, since integration represents area, I will consider total area as 1 unit. Okay, total area is 1 unit. Since it is symmetric about the line f of z, left hand side total area becomes exactly 50%, right? Therefore 0.5. Even right hand side also same thing, 50%, that means 0.5. Therefore 0 to entire left side total area is 0.5. Again from 0 to right side the total area is 0.5. Total it is 1. So try to remember this thing, okay, because all the problems we are finding the solution based on this understanding. Okay, now from this graph let us try to understand some basic notions. Now, integration minus infinity to infinity phi of z into dz. What is the value? It is simple, right? What they are telling, you find the total area from minus infinity to plus infinity. In the normal distribution, standard normal distribution, total area is 1. So that can be written as p of minus infinity to infinity, it is 1. Okay, what about second one? Integration minus infinity to 0 phi of z into dz. What is the meaning? You remember the graph, they are asking area from minus infinity to 0, correct? That means exactly half. What is the area? Since total area is 1, so half of the area means 1 by 2. Even 0 to infinity, that means right hand side. Since it is symmetric, there also area is 1 by 2. Or in other words, we can write p of minus infinity to 0 or p of 0 to infinity. The value is 1 by 2. So try to remember this. Total area is 1, exactly 50% is 0.5 or 1 by 2. Now, the next important observation, p of minus infinity to less than z1. What is the meaning? We have to find the area from the point minus infinity to the point z1. What I will do is, first I will find the value from minus infinity to 0. That is p of minus infinity less than z less than or equal to 0, plus from 0 to next point, that is z1. What is the area from minus infinity to 0? That is 0.5, right? That we cannot change. So 0.5 plus remaining area depending on the value of z1. Therefore, I will take it as phi of z1. Therefore, if p of z is less than z1, the total area is 0.5 plus phi of z1, where z1 is greater than 0. Similarly, if p of z greater than z2, then area is 0.5 minus phi of z2. So if it is less than plus, greater than minus. So try to remember this formula also. This is very much required in the upcoming problems. Fine. Now, as I mentioned earlier, now all the problems in the case we are doing with standard normal distribution, not with normal distribution. And in all the problems we have to use normal distribution table. This part is very, very important. If you know how to use normal distribution table, then problem becomes simple. Otherwise, we cannot solve the problems. Therefore, this part is very important. Listen properly. Now, suppose I want the value of phi of 1.55. They will give the normal distribution table. How to find the value? It's very simple. What we have to do is, first I will show the table. I want to find phi of 1.55. Okay, let us go to the table. I will show the table. Yes, so this is the table. So in all the problems we are using this particular table only. Now what I want? I want the value of 1.55. You see the first column. What is the first column says? Z. Okay. 1.55. You take first two values. That is 1.5. Okay, where is we'll get 1.5? You have to go down. Remember, always first you have to go down. Okay, go down I want 1.55. Remember, first I will take only 1.5. Where is 1.5? Yes, I got here, right? Okay. Now, what's the remaining value? 1.5 I took. Remaining value is 0.05. For that, you have to go for horizontally. Horizontally, you have to go. 0.05 is here, correct? You have to go horizontally. 0.05 is here. 1.5 is here. Therefore, the value of 1.55 is 0.4394. Hope you understood. If you want, I'll give one more example. Suppose they are asking 1.12. Remember, I want the value of 1.12. How to find? First, you take 1.1 vertically. Go down. Yes, I got 1.1. What's the remaining value? 0.02. So, go here. You get 1.12. Answer is 0.3686. Correct? Okay, I'll give one more example. Suppose they are asking 0.75. How to find? First you go for 0.7. Yes, it is here. Vertically down you have to go. Then remaining is 0.05. You have to go horizontally. 5, yes, here. So the value is 0.2734. So just to remember how to check the values using normal distribution table. So first step is go vertically down for the first two value. The third value, in the same thing, you have to go horizontally, how to find the value. And remember, this value is only for the positive. Remember, so 0 to right side the value. So we are not taking negative values. Why? It is a symmetric function, right? Although if they ask negative values, since it's a symmetric function, we'll take right hand side, we'll find the positive value, right? So answer remains same. I hope you understood how to find the value using normal distribution table. So this table you have to remember. First vertically go down for the first two value, remaining you have to go horizontally, right? So with this we'll go for simple examples. Only thing you have to do is you have to remember this graph, symmetry, and how to find the value using distribution table. Okay. For more understanding sake, we'll take some simple example. Okay. What is the first question? Find the area under the standard normal curve. SNC means standard normal curve between z equal to minus 0.86 to z equal to 0. Okay. As I mentioned, we are finding the value using standard normal distribution. Here we have to find from minus 0.86 to 0. First write on the graph. We know the graph, it is a bell shape. Write down minus 0.86. It is in the left side. First put a mark up to 0. So this is the area we have to find out from the figure 1. But what I mentioned, this is symmetric graph, right? Instead of finding the area from minus 0.86 to 0, we'll shift it to right hand side. That is the first quadrant. What we have to find out? It is same as finding the area from 0 to 0.86. Okay. So that is what I want. So I have to find out area from 0 to 0.86. That is phi of 0.86. So now you check normal distribution table. Again I will repeat how to find the value of phi of 0.86. Very simple. First vertically go down for 0.8. Then go horizontally for 0.06. The value is 0.3051. Please check once in the table. Okay, fine. Let's go for one more example. Find the area under the standard normal curve from the point z equal to minus 0.44 and z equal to 1.76. Whenever they have given the value, first write on the diagram. As usual, bell shape, minus 0.44 here, left extreme, and up to 1.76, that is right hand side. Now, since it is a symmetric function, what I will do is RHS value, that means right hand side value is 0 to 1.76, that is phi of 1.76, right? But I want little more, that is minus 0.44 to 0. That is same as finding 0 to 0.44, correct? Therefore, what I will do is I will find 0 to 1.76, that is phi of 1.76 I have given in the second diagram, plus 0 to 0.44, that is phi of 0.44. So I have given here minus 0.44 to 1.76 same as phi of 0.44 plus phi of 1.76. Check normal distribution table. Final answer is 0.6308. Okay, let us take one more example for your understanding sake. Find the area under the standard normal curve between the points z equal to 0.57 and z equal to 0.49. Okay, both are positive, right? Okay, fine. Let us write down the diagram. We'll find the shaded region. First point is 0.57. I have written the line up to 2.49. So that is the required region. Now how to find? Very simple. If you know the logic very well, it is easy. What I will do, first I will find the area from 0 to 2.49. What is that? Phi of 2.49, correct? Then I will find the area from 0 to 0.7, that is phi of 0.57, then subtract. So that gives the required area. Therefore, area between 0 to 2.49 minus area between 0 to 0.57. That is phi of 2.49 minus phi of 0.57. Using normal distribution table, find out these two values, subtract, the answer is 0.2779. I hope you understood. Let us take one more example so that you will get better clarity regarding standard normal distribution. Now, find the area under the standard normal curve to the right of z equal to minus 1.96. Okay, first you write on the diagram minus 1.96. I have pointed out. Right of that means entire thing, right? Right side from minus 1.96 to infinity. How to find? Very simple. What I will do is from 0 to remaining thing total area is 0.5, correct? That I no need to check. Remaining thing I have to check from minus 1.96 to 0. Since it is symmetric, it is same as finding the area from 0 to 1.96. Therefore, the total area is what? Area between minus 1.96 to 0 plus right side of 0. So, phi of 1.96 and right side of area from z equal to 0 is 0.5, right? So, phi of 1.96 plus 0.5. Phi of 1.96 is 0.4750 plus 0.5. The answer is 0.9750. So, these are the few examples regarding standard normal distribution. Only summary regarding this video is, you remember what is normal distribution, that we are represent in terms of x. Standard normal distribution we are represent in terms of z, and the relation is z equal to x minus mu by sigma. And all the problems we are solving in terms of standard normal distribution problem, and graph is bell shaped, which is symmetric about the line f of z. So, left side area is 0.5, right side area is also 0.5, total area is 1. So, and you have to find the value using normal distribution table. So, this is the basic of standard normal distribution. With this, we'll wind up this video. In the upcoming video, we'll take the standard problems from normal distribution. Thank you so much. Have a nice day.